So today is going to be an introduction to linear programming. And so when dealing with systems of linear inequalities, they are actually used to solve real life problems, which is kind of cool to see those connections. And a lot of times when we use systems of linear inequalities, it's because we're trying to find the optimization points of production or profit or item things. And so it's when we want to find the maximum or minimum value of a quantity. So the profit of producing these items or the cost of producing these items. And so lots of big corporations and businesses will use this on a regular basis to determine how many things they have to produce in order to make it worth their time and worth their cost. And so we call this linear programming. And it's a specific type of optimization that has linear inequalities, which we call constraints. And so what the constraints are, it's just a list of inequalities that our problem has to satisfy. And so it can be anywhere from just 2 situations to 5 or more. And so it's just basically a system of inequalities saying the stipulations that this item must possess. And we also deal with the objective quantity, which is another common term you're going to be hearing. And what this is, it is an equation. Remember, that's most important, not an inequality. It's an equation to maximize or minimize your cost or profit or whatever you're trying to find. And so your objective quantity will look a lot like P equals 3x plus 2y. Objective quantities are going to be something like that, where we have an equation where your profit or your cost equals some amount of x's plus some amount of your y's. And so constraints and objective quantity are 2 things we're going to be hearing about a lot. And we're also going to say the word optimization. We're going to ask you to optimize the different solutions to the problem. So when dealing with linear programming, you're presented with these real-world situations, and you need to come up with equations and inequalities to satisfy what's going on. And so the first thing you have to do is you need to write an objective quantity, or that equation, to represent the sentence below. It says the cost to produce X toys at $3 each and Y toys at $2 each. And so when thinking about an equation, the cost to produce toys, we have X toys at $3 and Y toys at $2. Right there, we just wrote our objective quantity. So we're trying to figure out what numbers would X and Y, or should X and Y be, to make it the most cost efficient. And so we're going to optimize this objective quantity. However, to do so, we have to have some constraints to follow. So this company that's producing these toys then also said, you have to make some of each toy, but you can make no more than 4 toys total. And so this is actually going to be 3 different inequalities. If we are going to make some of each toy, that means that we have to make more than 0 of X toys. We have to make more than 0 of those Y toys. And altogether, it can be no more than 4. And so right here we wrote our objective quantity, so that equation that we're trying to satisfy, and we also wrote the constraints that this must follow. And so what we're going to learn how to do is we're going to learn how to take this information and find the maximum minimum cost in order to satisfy this. Today we're going to practice mainly just graphing and finding your maximum minimum or your optimization. And then in a few days we're going to actually be writing these objective quantities and constraints on our own. So looking at this problem, here's our objective quantity, here are our constraints, and what we need to do is we need to graph. And so we need to graph our constraints, so a system of inequalities, and we want to make sure we shade. And so when I graph inequalities, I like to do it just like before, one at a time. And so x has to be greater than 0. So x is greater than or equal to 0. It's going to be a solid line. And then if x is bigger than 0, it would be all of these x's, because all the other ones are negative. So it's all these values over here that would work. However, we have more than just one constraint. Our next constraint, oopsies, says y has to be greater than or equal to 0. So here is our line. If it's going to be greater than 0, here are the y's that would satisfy that inequality. Notice our area of overlap is this first quadrant where we're really focusing on. So we can kind of cross these out because they're not going to work. And last but not least, we have x plus y has to be less than or equal to 4. In order to graph, we have to solve for y. So y has to be less than or equal to minus x plus 4. So 1, 2, 3, 4 minus x. And I can go ahead and make my line. And I also am going to pick the origin and plug it in to see what side to shade. So 0 is less than or equal to 4, yes. So I'm going to shade this bottom half. So right there, I have graphed and shaded for all of my constraints. Now, what we want to look for is we want to look at the area of overlap that we have. And so right here is where all 3 equations highlighted. So I shaded it in orange, green, and purple in that little triangle. And so we're going to take our objective quantity and we're going to plug in the vertices of the solution area. So my vertices are 0, 0, 4, 0, and 0, 4. And what I need to do is I need to test each ordered pair in our objective quantity to find the maximum minimum value. So I have 3 times 0 plus 2 times 0, which is 0. I have 3 times 4 plus 2 times 0, which is 12. And I have 0, 3 times 0 plus 2 times 4, which is 8. So my maximum quantity would be at 4, 0. My minimum quantity would be at 0, 0. Max, min. And right there, I found my optimized area. This area right here is going to give me the best results. Here's another example. We have our objective quantity on top, right here, C. So cost is 5x plus 4y. And we have our constraints right here. X is greater than or equal to 0, y is greater than or equal to 0, x plus 2y is less than or equal to 4, and x minus y is less than or equal to 1. So go ahead and graph and shade your constraints, and then come back and see what to do next. So if you look at my graph, I went ahead and I put in all of my equations and I shaded, and then this little black box is where all of my shading overlapped for all 4 equations. And so I have the vertices 0, 0, 0, 2, 1, 0, and 2, 1. And what I need to do is I need to plug in all 4 of these ordered pairs into my objective quantity to see which one maximizes and which one minimizes my cost. And so in doing so, I get 0, 8, 5, and then I get 10 plus 4, 14. And so at the point 2, 1, that would be my maximization. And the point 0, 0 would be my minimum. So I found my max and my min.